In physics today we're going to start a new topic which is called light. So light lays they travel in a straight line from the source. So the light lays they travel in a straight line from the source and they do not bend around the corner. And this is the reason why we are able to see objects. And the reason why we are able to see objects is because light travels in a straight line. So let us assume that this is the sun. This is the sun here. So the light that is coming from the sun, it will travel in straight line. So this, we can draw the direction of the light rays. So these, they travel in a straight line and they don't bend around the corner. So the light rays, they cannot bend around the corner, and that's the reason why we are able to see the objects. Then the next thing that we're going to talk about are the shadows. So a shadow is formed when light rays they strike an opaque object. So shadows, these are areas that are formed when light rays strike an opaque objects. So for example, if light is moving in this direction and when it reaches an opaque object, so as it is traveling, when it reaches an opaque object, it's going to form a shadow. And that's the definition of the shadow. This is the area that is created when the light rays they strike opaque objects. And these opaque objects are objects that don't allow light to pass through them. And examples of opaque objects, we have a house, a person, and a ball. Those are just some few examples of opaque objects. Then the shadows are referred to as the areas of darkness. So these are the areas of darkness. But sometimes, not sometimes, but light passes through some objects, and these objects that allow light to pass through them, they are referred to as the transparent objects. So I've said that shadows are formed when light strike opaque objects, and these opaque objects are objects that don't allow light to pass through them. And examples of opaque objects, I've said a person, a house, and a ball. Then the next thing that we're going to look at are objects that allow light to pass through them, and these objects are referred to as the transparent objects. So the objects that allow light to pass through them are referred to as the transparent objects. So these guys, they do allow light to pass through them. And examples, an example of a transparent object is glass. And the next thing that we're going to look at are objects that allow some light to pass through them. So they just allow some light to pass through them, and these objects are referred to as the translucent objects. So the translucent So these objects, they allow some light to pass through them. These are referred to as the translucent objects. I hope it's clear on shadows, but where you have questions, you can ask in the group. And the next thing that we're going to look at are the two types of shadows. So there are two types of shadows. We have the Umbra and the Penumbra. So we have two types of shadows. We have Umbra. Let me just write that down. Umbra and Penumbra. So we are going to start with Umbra. So Umbra is a type of shadow that is formed where light does not fall. So Umbra is a type of shadow that is formed where light does not fall. That's Umbra. And the Umbra are referred to as sharp shadows. And how this Umbra is formed, the Umbra shadows is formed where light comes from a small source. As they come from the small source, they are going to hit an opaque object. So I've said an Umbra is a type of shadow that is formed where light does not fall. So where light does not fall, and these are referred to as sharp shadows. Then the other thing that you must know about the Umbra is that they are formed from a small source of light. So small source of light. Let us now look at how the Umbra is formed by drawing the diagram. So for example, this is a small source of light. Then we have our opaque object here. Then we have this surface. So light will move to the opaque object. So this is a small source of light. Small source of light. Then here we have our opaque object. And this is just the surface to reflect the this is the surface that will just show the shadow. So just this surface. And the shadow that is going to be formed is this type of a shadow, and this shadow is referred to as the Umbra. So the Umbra is the type of shadow that is formed where light comes from a small source. So as it comes from the small source here, it's going to strike the opaque object, and the opaque object here is going to form a shadow which is referred to as the Umbra. So this is also referred to as a sharp shadow. Let us look at Penumbra. So the next thing that we're going to look at is Penumbra. So Penumbra is a type of shadow that is formed where some light falls. So it's a type of shadow that is formed where some light falls, and this type of shadow is referred to as a partial shadow. So the Penumbra is also referred to as the partial shadow. Then the Penumbra is formed where light comes from a brighter source. So the Penumbra is formed where light comes from the brighter source. So I've said this is a type of shadow that is formed where some light falls. So where some light falls. Then the other thing that you must know that these are types, or these are partial shadows. Then they are formed where light comes from a broader source. Let us look at how these are formed. So here I have a broader source of light. So I have a broader source. Then here we have an opaque object, and this just shows the surface that is going to display the shadow. So as light comes from the broader source here, it will strike the opaque object, and our face shadow here is going to be formed. So we have this face shadow, this part. So this will be the dark shadow. Then our next shadow, as light falls, it's also going to be formed. So this shadow that is formed, that has some dot where some light falls, this is referred to as penumbra. And this type of shadow is referred to as umbra. So that's all about the penumbra and the umbra. Where there are some questions, you can ask in the group. The next thing that we're going to look at is refraction. So refraction of light is the next thing that we're going to look at. So refraction is defined as the bouncing back of light. So the main reason why we are able to see objects is because light is reflected into our eyes. And when light is reflected into our eyes, we are able to see objects, we are able to see houses, we are able to see all these different kind of things. You're able to see the television, you're able to see the refrigerator, you're able to see a lot of things, and this is because of refraction. And the other thing that we're going to talk about on refraction is how refraction looks like. So I've said refraction is just the bouncing back of light. So this is the bouncing back of light. And let us look at how refraction looks like. So for example, this is a reflecting surface, and this reflecting surface can be a mirror, and we have this line. So this line is referred to as, okay, I'm going to label it first. Then we have this line, we have the other line here, we have this direction in that direction, we have an angle here, we have another angle here. Let us now look at the parts. So the ray that strikes the reflecting surface of the mirror, this is referred to as the incident. This is referred to as the incident ray. Then the ray that is drawn 90 degrees to the reflecting surface, this line that is straight, is referred to as the normal. Then the ray that leaves the reflecting surface, or that strikes the reflecting surface, is referred to as the refracted ray. Then we have angles here, so I can represent them by I and R. So here I stands for angle of incidence. It is referred to as angle of incidence. So this is angle of incidence. Then the R is referred to as the angle of refraction. So angle of refraction. So I've said that the incident ray is the ray that strikes the refracting surface. The refracted ray is the ray that leaves the refracting surface. Then we also have the normal. So the normal is the line that is drawn 90 degrees to the refracting surface. Then we have the angle of incidence here, which is represented by I. So the angle of incidence is the angle that is between the normal and the incident ray. As you can see, it is in between the incident ray and the normal. Then the angle of refraction is the angle that is between the refracted ray and the normal. So that's how refraction looks like. Let us look at the law of refraction. So the law of refraction. So this one usually comes in the exam. They're going to tell you, can you mention the law of refraction? So the first law of refraction is that the incident ray and the not the incident ray, sorry, the angle of incidence and the angle of refraction are always equal. So the angle here and the angle here, they are always equal. So I've said the angle of incident and the angle of refraction are always equal. So we can say I is equal to R. But when you're giving in the exam, make sure you write the whole statement. Then the other row on the row of refraction, we can say that the incident ray, the normal, and the angle of incidence, they always lay in the same plane. So as you can see here from this diagram, the incident ray, the normal, and the refracted ray are this side. We can say they are on the bottom part. So these always lay in the same plane. So sometimes you can draw them upwards, downwards, to the right side, to the left side. But you must know that the incident ray, the normal, and the refracted ray, they all lie in the same plane. So here you can say the incident ray, the normal, and the refracted ray they all lie in the same plane. They all lie in the same plane. So these are the main 2 points that you need to know. And now let us look at the next thing. So the next thing that we're going to look at on refraction is are the two types of refraction. So we have two types of refraction, and this is regular refraction and irregular refraction. So there are two types. So I've said the types of refraction. So types of refraction. So I've said there are two types. There is a regular and irregular. So irregular is also referred to as diffuse refraction, So in some books, you're going to find that they're going to just write two types of refraction as regular refraction and diffuse refraction. They may not write irregular refraction, but you must know that irregular refraction is also referred to as diffuse refraction. So what is regular refraction? So regular refraction is a type of refraction that comes from smooth surfaces. So this comes from smooth surfaces. Smooth surfaces. Then what about irregular or diffuse refraction? So this is the type of refraction that is formed from irregular, from rough surfaces. Sorry. So this is the type of refraction that is formed from rough surfaces or surfaces that are not smooth. So rough surfaces. Let us now look at the images that are formed by the mirror. So there are some properties that you need to know by there are some properties that you need to know that are formed by the mirror. So for example, we have the mirror here, and the image that is produced by the mirror, first thing, it is virtual, and this means that it is not real. So not real. And what virtual means is that it's a type of image where light does not reach a certain surface. For example, if you look yourself into the mirror, it actually shows that the light is coming from the mirror, then it is going into your eyes. But that's not real. The real thing is that the light strikes the mirror, then from the mirror the light is going to go into your eyes. That's why you're able to see yourself into the mirror. It's not like the mirror. It's not like the light is coming behind the mirror. So that is what virtual means. So virtual means not real. So the other property of the image that is formed by the mirror is that the image is inverted. This means that the right and the left are opposite. So light and left are opposite. Then again here, the image has the same size as the object. So same size. Then the image is also upright. So these are some of the things that you need to know on refraction. Where you have questions, please ask in the group before we go any further, before we start having any complications. Thank you very much. The next thing that we're going to look at are the laws of refraction. So there are two laws of refraction. The first law states that the incident ray, the refracted ray, and the normal at the point of incident all lie in the same plane. The incident ray, the refracted ray, and the normal at the point of incident all lie in the same plane. And the second law states that for any two particular media, the ratio of the sine of angle of incidence to the sine of angle of refraction is constant, and this is given by the formula n, which represents the refractive index, is equal to sine of angle of incidence over sine of angle of refraction. So these are the two laws of refraction. So there are only two laws. So the first law states that the incident ray the refracted ray and the normal at the point of incident all lie in the same plane. So at the point of incident all lie in the same plane. So this is the first law, and the second law states that for two particular media. So let us look at the second law, and you must know that the second law is also referred to as the Snell's law. So this states for two particular media, the ratio of the sine of the angle of incidence to the ratio of the sine of the angle of refraction is constant. So it's constant. And from this definition we can actually write another formula that you can use to calculate the refractive index. So n represents the refractive index is equals to, we say, sine angle of incidence divided by sine angle of refraction. So let us look at an example. So the example reads, calculate the angle of incident when light travels from air to glass. The refractive index of glass is 1.52 and the angle of refraction is 20 degrees. So the refractive index we have been given, so we need to correct our data. The refractive index we have been given as 1.52 and the angle of refraction we have been given as 20 degrees, and we have been told to calculate the angle of incidence. And we know that we can use this formula which says our refractive index is equals to sine of angle of incidence divided by sine of angle of refraction. N here have been given as 1.52 is equal to, we are trying to calculate the angle of incidence, so we're going to say sine I divided by sine the angle of refraction have been given as 20. So divide by 1, cross multiply here. So I have sine I is equals to 1.52 multiplied by sine 20, the answer is 0.520. So the answer is 0.520. And to calculate the value of angle of incidence here, I'll say angle of incidence is equals to sine inverse of 0.520. So sine inverse of 0.520 is giving me 31.33 degrees. So this is how you can calculate the angle of incidence when you have been given the refractive index and the angle of refraction. So I hope it's clear on the laws of refraction. Let us look at the next thing, which is the real depth and the apparent depth. So the next thing that we're going to talk about is the real and apparent depth. So the refraction of light at the surface of water makes ponds and swimming pools appear shallower than they really are, and it makes objects under the water appear to be nearer to the surface than they really are. So if you place a coin into a bucket that contains water, you're going to observe that the coin is going to appear as if it is near the surface of water, and the reason why it appears in that manner is because of refraction. Then when you see an object below the water's surface, it is because the sun's rays have refracted off that object and then passes through the water into the air. Because of the change in medium, the light is refracted before it reaches your eyes. Your brain interprets the position of the object as being in a straight line at some point away from your eyes, at the apparent depth, which is shallower than the real depth of the object. So if you place a coin into a bucket that contains water, you're going to observe that the coin is going to appear near the surface of water. So at that position, that is referred to as the apparent depth. But if you take a close look at the coin into the dish, you're going to find the real depth, and we can use these two distances to find the refractive index. So when we use the real and apparent depth, we say refractive index is equal to the real depth divided by the apparent depth. So this is the formula that you use. It's actually a simple formula. So for example, if you have been given the real depth, so RD, if you have been given as 10 meters, and the apparent depth, if you have been given 5 meters, and you have been told to calculate the refractive index, so we're going to say N is equal to the real depth divided by the apparent depth. So we are going to say N is equal to the real depth there is 10 divided by 5, and the refractive index there it's 2. Let us proceed. Let us look at the critical angle in total internal refraction. So I've said we're going to look at the critical angle. critical angle and total internal refraction. And I'm going to use a diagram to explain the critical angle in total internal refraction. So for example, if we have this diagram here that shows refraction, then here we say there is water, and here there is air. If we take, for instance, this is just the initial movement of the light ray. So it moves from water to air. So as you can see here, the angle of incidence is small because water has a high optical density, and the angle of refraction, it's actually big because air has a lower optical density. So this is just the initial drawing, but let us take, for instance, we start increasing the angle of incidence here. If we start increasing the angle of incidence, this means that also the angle of refraction will start to increase. As we continue increasing the angle of incidence, the angle of refraction will become 90 degrees, and when that happens, that means that a critical angle will be formed. So this means that if we increase the angle of incidence here by this margin here, and we find that the light ray now moves straight to the boundary here, that means now the critical angle will be formed here. So it will be represented by IC. So that's how the critical angle is formed, where the angle of refraction becomes 90 degrees. Let us now talk about how total internal refraction occurs. So total internal refraction occurs when we increase this angle, this critical angle, if we increase this critical angle. So for example, if we increase by this margin, by any margin, as long as we have increased the critical angle, total internal refraction is going to be experienced. Instead of this light ray that had been refracted towards the boundary here, it's going to be refracted inwards, and when it is refracted inwards, that will be refraction, not refraction. It will be refraction. And when refraction occurs, we know that the angle of incidence and the angle of refraction will be equal. So that's about the critical angle in total internal refraction. But let us look at what the note says. So it says, when light travels towards a medium with a lower refractive index, it bends away from the normal. If we increase the angle of incidence, the angle of refraction becomes 90 degrees. When the angle of refraction becomes 90 degrees, when the angle of refraction becomes 90 degrees, the refracted light now skims along the surface between the media. The critical angle is different for different materials. For glass, it is about 42 degrees. When the angle of incidence is greater than the critical angle, the light ray bends so much that it is reflected back into the medium. When this happens, the light cannot undergo refraction. This is called total internal refraction. So that's about total internal refraction and critical angle. Let us look at different diagrams that shows the critical angle and total internal refraction. So the first diagram that I'm going to draw, I'm just going to draw the normal one. So this is water and this is air. and the light ray is moving from water to air here. So the angle of incidence there is smaller, but the angle of refraction is actually bigger. And we take, for instance, we increase the angle of incidence here. The normal must be a dotted line. And if we continue increasing the angle of incidence, it will move straight to the boundary here, and the critical angle here will be formed, which is IC. So here we have water, and here we have air, and the 90-degree angle here will be formed. What about total internal refraction? So total internal refraction is where we increase the critical angle here. So if we increase the critical angle there, total internal refraction is going to be experienced. So this is water, and this is air. So the light ray will be reflected into the medium. So we have the angle here, the angle of incidence, and the angle of refraction. And these two angles, they are equal to each other. So we can say I is equals to R. Then let us proceed. Let us look at the relationship between the critical angle and the refractive index. So the relationship between the critical angle and the refractive index, the relationship between the critical and refractive index So we know in the formula that we used, we say our refractive index is equals to sine I divided by sine R. And take for instance that we have the critical angle that has been formed, we can say n is equals to sine 90 divided by sine critical angle. So this is the formula that you need to know between the relationship between the critical angle and the refractive index, and we can actually simplify it. We can say n is equals to sine 90, that's 1 divided by sine critical angle there. And let us look at an example. So if the example says calculate the critical angle for a material is 42. So calculate the critical angle for a material is 42. The first question, the question reads, what is the material's refractive index? So that angle that we have been given is the critical angle. So the critical angle, let's just correct our data. The critical angle we have been given as 42 degrees, and we are being told to calculate the refractive index. So we don't know. We say refractive index is equals to 1 divided by sine critical angle. So n is equals to 1 divided by sine 42. And if you do your math there, n will be equal to 1.49. So that's the refractive index of that material when the critical angle is 42 degrees.